We now want to give an introduction to functions, and the idea of a function is it's going to describe the dependence of one quantity on another. So a good example of this is how height depends on your age. How old you are then determines how tall you're going to be. So height would be a function of age. So this is a very informal way to think about a function, so let's try to define it a little more precisely. So in reality, a function is just a rule, and we represent these functions with letters like f, g, and h. And when we write something like f with this parenthesis 3 that's read f of 3, what this means is we want to apply our rule f to the number 3. A more precise definition of a function f would be a rule that assigns to each element x in some set A exactly one element called f of x in the set B. So this set A, where our x is, this is called the domain, and the set B is called the range. So let's try to look at some examples of exactly what we mean by this definition. So this is an example of a function given in table form. So I have a list of all the values x can be, and I have their corresponding output for f of x. And you'll notice that for every single x, we have exactly one element y. Here's another example. I have a set x, and I have my corresponding f of x. This time you'll notice -2 gets assigned to 4, and 2 also gets assigned to 4. And this is absolutely allowed with functions, as long as for every single x we get exactly one y out of it. It doesn't matter if the y's are repeated. And this right here would be an example of something that's not a function. In particular, if I look through my x row, you'll notice that we have 2 assigned to 4 and 2 assigned to -4, and this becomes a problem. So we can have our f of x repeated, but we cannot have the x's repeated. Every x should go to only one value for y, or for f of x. This is another way to represent a function called an arrow diagram. So the first thing has all of my values of x, the second one has all my values of f of x, and the arrows just correspond to what the rule says. In this case, f of 1 would be 0, f of 2 is 7, f of 3 is 2, and f of 4 is 12. Here is another arrow diagram that represents a function. You'll notice that both 1 and 2 get mapped onto f under my rule f, but this is completely allowed. We are allowed to take 2 different values for the first set A and map them to the same thing in B. This one, on the other hand, would be not a function, in particular because this value of 3 gets mapped to 2 things, and that's not allowed. This one is also a function. You'll notice this 1 on the right-hand side in my set B has nothing that goes to it, but that is perfectly allowed for our functions. This one is another example of something that's not a function. So the rule for a function says that everything in the first set must go to exactly one element in B. And this 4 right here does not go to anything, so this would be not a function. Now that we have a little bit better of an idea of what a function is, let's get familiar with some of the notation. So let's suppose I have this function f of x equal to x squared minus 2. And I want to find f of 2. So what this means is take all of your x's and change them to 2. So 2 squared minus 2 would be 4 minus 2, which is 2. If I try to find f of -3, I would have -3 squared minus 2, which is 9 minus 2, or 7. I could do f of the square root of 7. That would be the square root of 7 squared minus 2. The square root of 7 squared is 7, minus 2 is 5. We can also think about what our domain is and what our range is. So the domain is all of the values that I can stick in for x. And here I can stick in every single number for x. There's no real restrictions. However, there is a restriction for my range. The key here is to realize that that x squared term will always be either 0 or positive. It can never be negative. So the absolute smallest thing this could be would be 0 minus 2, or -2. And it can grow as big as we need it to, but the absolute smallest thing we can have is -2. Now we have this. This is 2x squared plus 3x minus 4. I want to try to find f of negative 1. So I would have 2 times negative 1 squared plus 3 times negative 1 minus 4. So 2 times negative 1 squared would be 2. Minus 3 minus 4 is minus 5. If I wanted to try to find f of 0, I would have 2 times 0 squared plus 3 times 0 minus 4, which ends up being just minus 4. And so we can start to see how this would work. Let's look at a slightly more complicated example. This is called a piecewise function. And so the idea is it's defined in pieces. So in this case, we're looking at a cell phone plan that costs $49 a month. And this plan includes 2 gigabytes of data, for free data. And then after that, it charges $10 per gigabyte for any additional data used. So this whole first row says that if we use somewhere between 0 and 2 gigabytes, we're going to pay the flat rate of $49. The second row, if we use more than 2 gigabytes, so if x is greater than 2, we're going to pay the $49 plus an extra $10 for everything over that 2. So I want to find c of 0.5. Well, 0.5 is between 0 and 2, so I'm in the first case here, and I would just spend $49. C of 2, you'll notice the first case says 0 less than or equal to x or less than or equal to 2, so 2 is also included in that first case. However, if I want to look at 4, now I'm bigger than 2, so I'm in the second case. 49 plus 10 times 4 minus 2, which if we work out is 69. So if we used 4 gigabytes of data, it would cost us $69.